Okay, so on to question number 9. What is the electron configuration for B? So vanadium. So when we want to find the electron configuration of an element at its ground state, we can go by the following steps. So the first step is to divide your periodic table into sections. Okay, so I can show what that looks like so that it's kind of easier to visualize. But most of the time you're given a periodic table during like an exam, so you want to make sure you know how to divide the periodic table into these sections. So for the S block, it is the first 2 rows, or columns, sorry, plus helium. So it is shown in light blue, and this is the S block. For the P block, it is this green kind of rectangle, and then the D block is this orange, so it is all the transition metals. And then lastly, the F block are the last 2 rows, which are the lactanides and the actinides. So part 2 is starting from hydrogen. You want to move left to right across the periodic table until you get to your desired atom. And then you want to write your row number and then your block letter. And then I'll also note when you get to your D block, you write your row number -1. And if you get to the F block, you write your row number -2. Okay, so this will make more sense once we start doing the example. So the example is looking for vanadium. So first, let's find it on the periodic table. And you can see that is right here, atomic number 23. Okay, so let's follow the steps. Starting from hydrogen, if we were to move left to right across the periodic table, we write the row number and then the block letter. And then you also want to show how many electrons there are in each orbital as you go through it. So starting at hydrogen, it's 1s over to the helium, so you get 1s2. And then on to the next row, we have 2s2. And then moving across to the P block, we are still in row 2, 2p, and then if you were to count everything in that row, it'll be 2p6. And then down to the next row, we have 3s2, and then 3p6, and then 4s2. And then when we get to the D block, it becomes 3d, and then we want to count up to vanadium. So it is 1, 2, 3. So 3d3. So this is the long version of the electron configuration. So if we wanted to write this using the shorthand electron configuration, it's pretty simple. You just need to look at the noble gas that comes before vanadium. So in our case, it is argon. So we write argon in square brackets, and then we just continue on writing the remainder of the electron configuration, just doing the same way we've been doing, 4s2, 3d3. Okay, so let's see what the junior tutor said. The atomic number for vanadium is 23. The noble gas that precedes vanadium is argon. Hence, the electron configuration for vanadium is argon. So here, doesn't matter. You can write it the 3d3 first, or s2. And this is because the 3d3 has a lower energy than the 4s2. And then they can show the orbital box diagram. So you can see here how the 4s has a filled orbital, and then for 3d3 you have 3 unpaired electrons. Yep, so this solution is correct. Okay, so on to question number 10.